All right, today is a little bit of review for the big final, and I want to start with probability. I actually have had more questions about that. I had somebody even walk up to me at the beginning of the hour, can we focus on probability today? So I'm going to do a few of those, and then I'll do a few of the other kinds. But probability has one really hard kind in it called binomial probability. And it's kind of like Inception. You remember the movie Inception? How many of you have seen the movie Inception? All right, it had a dream, and then there was a dream within the dream. Well, this is a probability within a probability. They give you a probability, and then they ask you to use that probability to figure out a different probability. So here is the probability question I want to pose to you. Let's say you are an 80% free throw shooter. Would you agree then you would expect if the kid was going to take 8 shots at the end of the game, they'd probably make 8 out of 10? And I mean, assuming that there's no extra pressure or whatever, okay, so they probably should make 8 out of 10. But what is their actual probability of making 8 out of 10 shots if you're normally an 80% free throw shooter? You need one of these dealy bobs to set that up. A C and then 2 parentheses. And you go like this, 80% chance of make, and this then is what? 20. And then the C is for how many shots you have that you could take, and you're going to take 10 shots, and then we want you to make 8. So it's 10C8, and then 0.80 to the 8, because there's 8 makes it, and then there's 2 misses. I'd like you to begin with here, just grab your graphing calculator and type that one in, because I would expect that the person would probably make 8 out of 10, but the probability of it actually happening is kind of low, surprisingly low. I think you're going to find that it's in the neighborhood of 30%, but figure it out exactly. Get your calculator. If you don't have one, borrow one from me. I got extras up here. All right, so here's how you type this puppy in. 10 C8, and the C is under the math button, and then you arrow over to PRB, and then you choose NCR, 10 C8. And by the way, sorry, not negative, got to clear that off. There, 10 C8 is 45. What is that? That's the number of paths on a great big tree chart, okay, that probability chart that looks like a tree. That's how many paths would be possible where you would make 8 and miss 2. And then the probability you do each time would be 8.8s, so you go 0.8 to the 8th, and 0.2 to the 2nd. I'm going to take this times 0.8 to the 8th, and then take that and times it by 0.2 to the 2nd. And there we have it. It's only about a 30% chance. Isn't that weird? If you're an 80% free throw shooter, there's only a 30% chance you're going to actually make 8 out of 10. Put that in the newspaper. Most people would be like, that's wrong. If you're an 80% free throw shooter, there's like a 90% chance you're going to make 8 out of 10. No, it's only a 30. Why? Well, there's a lot of people that will not make 8 out of 10. What will they make? Yeah, a little bit more, a little bit less. Like there'll be a lot of people that will actually make 9 out of 10. They do a little better than normal. Or a fair number of people choke and do like 6 out of 10 when they should normally make 8 out of 10. All right. So you have to add all those up, and what they would all add up to is 100%. So 30% is a big chunk of it. If you go up a notch and figure out what's the probability of making 9, and then you figure out what's the probability of making 10 out of 10, then what you've just figured out is one of the hardest probabilities of all, which is when I say at least. I could change the problem to say, what's the probability they're going to make at least 8 out of 10? Yep, we just figured out the probability of making exactly 8 out of 10, and it came out to 0.301. If we figure out then the probability going 10 C9 and 0.8 to the 8th and 0.2 to the 2nd, that's probability of making 9 out of 10. Oh wait, I screwed that up. 9 and 1, sorry. 9 makes and 1 miss. And then we go 10 out of 10 is 10C10, 0.8 to the 10, and 0.2 to the 0, which doesn't really hurt because 0.2 to the 0 is equal to 1. All right, so anyway, that would be the probability of making at least 8 out of 10. So could you agree that saying at least is like saying this, or this, or this? And what are we supposed to do with ors? Add them. Okay, so that's some of the hardest core probability that we have. Now somebody that asked me about probability, is there any other kind that you'd like to cover within probability? Do an extra practice on, whatever. So I'm going to do one. It's just if you want me to guide you the way you want, tell me which kind you want. Otherwise, I'll make up one. Any other kind of probability you want to see? Okay, then I'm going to give you the other big kind that's kind of the hardest kind are where you have a given in your problem. And so I'm going to use a Venn diagram and do a given. There we go. And let's say this is the person has an iPad, and most people here have an iPad because they're at the school and they give you an iPad, but it's unless you're a senior. And so anyway, the 0.2 could be people that have an iPad and a snuggle. Isn't that kind of blanket that's like, oh, Snuggie. But Snuggie has a totally different connotation at a high school. Isn't that where somebody grabs your underwear and pulls them up? Oh, wedgie, that's right. I swear, back in the old days, it was called a Snuggie. But anyway. There actually was a guy who died from having an atomic wedgie. An atomic wedgie, in case you don't remember this, is where they pull up your underwear and they pull it up so high that they wrap it over your head. And this person actually was killed. So there's somebody in prison today who can honestly say that he is in prison because he gave somebody an atomic wedgie. And it killed the guy. And it probably didn't help that the guy was really drunk that he did it to, and he left them that way. So anyway, he was trying to be funny, I think, and then killed the guy. Okay, so moving on. Okay, this doesn't add up correctly. You were right. I need to make this add up to a total of 100%, so I'm going to make that a 0.1. All right, so a Snuggie, as opposed to the wedgie, a Snuggie is that blanket thing that kind of wraps around you on infomercials and stuff. All right, and so this is the neithers. I would like you to take this seriously now and figure out what is the probability given the person had a Snuggie that they also had an iPad. Given that they had a Snuggie, what's the probability they had an iPad? You can leave it as a fraction if you want to, or you can divide it and get the decimal for me. Either way, I'd like you to billboard it my way so I can tell you gave this one a shot, and I'll try to tell you if you're right or not. All right, I don't know the decimal yet. Okay, I'll make sure I get this right here. All right. I'm getting a lot of the same, that's just good, okay. But there's definitely different answers out there. Okay, thank you. I didn't tell you what was right because I was not confident because I had really smart kids giving me different answers. So I'm going to do it. Here we go. This is what's given, right? Would you agree that those get added together and put where? On the bottom. If I add 0.1 to 0.05, that's like 10 cents being added to a nickel. It's like 15 cents. That needs to be on the bottom. And then what I wanted was the iPad. The person also had an iPad. That's these people. And only these. You can't use those. So then that's 0.10. Now, does it have to have that 0 there? 0.1 and 0.10. Are they different or are they the same? The same. So it's okay if you said it this way. A lot of people said it that way, and that was good. And then I got a lot of different decimals for that. Maybe that's because you divided wrong or something. No, I don't know. But if you take 0.1 and you divide it by 15, it's exactly like taking 1 divided by 15. And you get 0.66. It's not 1. It would be like 1 divided by 1.5. Sorry, if I move the decimal over. So you get 0.66666. So I'm going to round that to 0.67. About 67% chance. Any questions about that one? Yes, sir.
Is that a 1 ahead of the 0, or is it just a line?
That's just an ugly 0. I will change that for you. Maybe that's why I had different answers. Okay, because my writing was sloppy. I apologize for that. All right, let's move on. That is a probability type question. Let's do a CC over C. And let me just tell you a few situations that would work for CC over C. Always these are probabilities, because if you're dividing it, it's a probability. If I said, what's the probability that they're going to give you the pizza that you want, which is going to have 1 cheese and 1 meat and 1 sausage, out of all the different 1 meat, 1 cheese, and 1 sausage pizzas that they could make. Okay, the card questions are the same thing. If it's, what's the probability you're going to get 2 8s, a 10, and a jack if you're dealt 4 cards? Okay, that's a CC over C question. This, why is it, what? Okay, I will make it a pizza question. So everybody start with a CC over C like this and try to figure out what to put here. All right, let's just do this with cheese and different kinds of cheese and different kinds of meat. Okay, would you agree that at most pizza places you can order 2 different kinds of cheese? If you don't know that, it's true. So you can order, let's go with, there's 2 cheese options, choices, and then there's, let's say that there's 4 meats you could pick from. Okay, the question would go like this. What's the probability, given that they're only going to choose 1 meat and 1 cheese? Actually, I said that wrong. Probability that they're going to choose only 1 meat and 1 cheese, that it will be the one that you like best. And there's only one kind of pizza you like best. Let's say it's pepperoni and cheddar cheese. Okay? What's the probability you'll get the one you like? And there's only 1 meat being chosen and 1 cheese being chosen. Okay, when I say CC over C, does that mean that there'll always only be 2 C's on top? No, sometimes there's 3 C's on top. Usually there's only 1 C on the bottom. Could there be more than 1 C on the bottom? Yes, there could. It could. All right, so remember this. It's what you want on the top and what's possible on the bottom. Do you get that? Okay. Let's make this cheese and let's make this meat. Of the cheese options, how many did you want? How many choices were there for the one that you wanted? There was only 1 choice because there's only 1 kind you wanted. And you're going to get that kind you wanted. And then there's only 1 kind of meat that you wanted, and you're going to get that kind of meat that you wanted. And what could you replace this whole top thing with then? 1. Because really, isn't there only 1 kind of pizza that you wanted? All right, so that's a complicated way to do CC over C, but all of the top C's, they just become 1. All right, on the bottom, what were all the possibles? How many cheeses did they have to choose from? 2, and how many were they going to pick? 1. And how many meats did they have to choose from? 4. How many did they actually pick? 1. So the top would just be 1. Don't bother calculating all that. But the bottom, you'd do 2C1 times 4C1. That's a tougher than average one because there's two C's in the bottom. A lot of times there's only one. But why do we have to have two? Because there's two kinds of things. There's cheese and meat. We can't just put that all into one C because they're different things. All right, so it was a given question too in a way because I said they were going to pick only one meat and one cheese. Is it possible you could have a pizza that has two kinds of cheese and no meat? Not in this problem it isn't, because I said there was going to be one meat and one cheese. If you wanted to change the problem where it could be you could have two meats and no cheese, that'd be a little weird for a pizza. Or you could have two cheeses and no meat. If you want to change it that way, we could make it just one C on the bottom. And we'd say there are 6 toppings and you're going to choose 2 of them. Could have done it that way, but then that, again, it leads to weird pizzas that don't have cheese. All right, let's do a more normal CC over C kind of question. Let's do it with cards this time. And let's say that it's a 52 card deck. And let's say that I want you to try to tell me the probability of getting 4 aces and then a 2. What's the probability of being dealt 4 aces and a 2, given that you're going to be dealt 5 cards? Last time I put limitations on my pizza, and that made me change the bottom to a given, weird situation. This time there are no limitations. You could get any 4 cards in the deck. So there's 52, choose 4. Because there aren't any limitations. There was no given that you're going to get a this or a that. Did I say 5 cards? I'm sorry. Okay, 5 cards. Then I was saying you were going to get 4 aces and a deuce, right? This is aces. This is 2s, otherwise known as deuces. And there's 4 aces in the deck, and I want all 4 of them. There's only one way to do that. That's why when you do 4C4, the answer is 1, because you can only get that one way. There's not any different ways to mix it up, because the order doesn't matter. Times by, there are 4 deuces in the deck, and you want 1 of them. There are 4 different ways to do that, because you could get 4 different deuces. You could get the club, the heart, the diamond, the spade. All right, you multiply that all out, it's going to be a very small chance. Think about it. Do you think it's common that people get dealt 4 aces? Extremely rare. Really, really, really rare. Do you think it's more common in the game of, what's it called again? Where you have only 2 cards? Texas Hold'em. You think it's more common to get all aces then? Yeah, it is, because there's only 2 cards being dealt, and you just need 2 out of the 4 aces. So Texas Hold'em getting 2 aces, it's actually about 1 out of every 200 hands. So if you play 200 hands, which is actually possible in a night, if you're playing with a bunch of people, play 200 hands, this could happen, then you're actually fairly likely to get dealt 2 aces sometime during the night. Question? Okay. All right. So did somebody have the final answer on this one so I can compare and see if we have it right? 1.53 times 10 to the negative 6th. So 0.0000, that's 45153. There's your probability. That's why you don't see it too often. Anybody agree with that one? Got the same thing? Yep, several people agree. Okay, good. Then let's move on to not probabilities. There's so many kinds of probabilities. We could do expected values. We could talk probability for 2 hours straight, so I'd rather move on. You could always ask me individual questions later. I want to do one kind where you have, this kind of was one of the tougher quadratics questions, and it had to do with being given a graph, and they give you 2 points on the graph, like let's say a 1 here and a 5 here, and then they say, what's the vertex? Now, I have to tell you a couple things. First of all, I have to tell you if there's a stretch factor, because if there's a stretch factor, you don't know, because then it could be here. That could be a stretched out parabola, right? But if it's not stretched, that's an important thing to tell you. Do you know that it has to be on this line right here? Yeah, it has to be somewhere on that line. What's that line called? Axis of symmetry. Okay? You know it's on that axis of symmetry, so it's 3 comma something. Figure out where the vertex is. I'll pause for a second and see if you can do it without my help. There's no stretch factor, and it's a normal parabola, as in it is the vertex has to be down here somewhere because it can't be, it's not a flipped over parabola. It's a normal parabola. All right? Okay, you can guess and check your way to figuring this out. You go like, okay, what if it was here? And I go over 2 and up 2. That doesn't seem right. What should it be? Over 2 and how much? Over 2 and up 4 is the normal thing for a parabola. So then you could logically reason that it has to be there. Because that way I can go over 2 and up 4. You get that? That's one way to do it. That is probably the easier way, but that's not always going to work because sometimes it's a decimal. So how can I make sure it always works? Do you know how to write the equation for this thing? I do. I hope you do. If I was going to write the equation for this, I go y equals, and I have 2 sets of parentheses because that's where you're going to put the roots or the zeros, right? And then what would the equation be? It would be x and an x and then what? Come on, you can do this. Minus 1, which was taking this one, and then that one, minus 5. Why? Because if I put the 5 in there now, it makes it equal 0. Put the 1 in there now, it makes it equal 0. Those are the zeros, also known as the roots. Did I just write the equation for it? Yes. So if that's the equation for it, how can I get the vertex? Well, there's 2 ways. One way is you could multiply it out and then do the complete the square thing. That would be really smart, but it'd be kind of hard and take a long time. Another option, do you agree that this dot has to be somewhere on this dotted line? Therefore, the x of it is 3. And therefore, it's going to look like this, 3 comma something. And then how do I figure out the y? I take the 3 and stick it in this equation right here. So if I put a 3 right there, and I put a 3 right there, I get 3 minus 1 is 2, 3 minus 5 is negative 2, 2 times negative 2 is negative 4, and that's what I said it would be from the guess and check method. So either way, it works. Raise your hand if you had that one right. Okay, good. Are there any questions about how that would work? Yes, sir. I did address that in the original questions. I said you have to know ahead of time that this thing is not flipped and that the thing has no stretch factor. Because if it did, then everything would change. All right. Quadratics. Last one. I want to give you a quadratic. I want to see if you can use a quadratic formula. A lot of kids were awful at this. You remember that one test on the back side? A lot of people, like, seriously, I had tons of 6 wrong on the back side, which was like taking off 2 grades off your test. So a lot of people bombed this part. Here is your equation, 2x squared. Use a quadratic formula, please. Minus 7x minus 4. I know if you worked at it, you could find the factoring for this one, but please don't. Because when you factor it, most kids get it right. And so I'm not worried about that kind. I'm worried about the quadratic formula kind. So put this puppy in the quadratic formula, work it all the way down, and you will get 2 answers. I will tell you ahead of time, if you're doing it right, you'll get one answer that's a fraction and one answer that's a nice, simple whole number. I'll pause while you're working on that. Okay, here's how this should have gone. X equals negative b, which is 7, plus or minus the square root of b squared, which is 49, minus 4 times a times c. I always put parentheses there because I often have kids mess up underneath the root. In fact, I would bet that if 5 people took this, 5 people got this one wrong, that 4 out of the 5, you'd find out their mistake was underneath the root. It's really, really common. All over 2a means 2 times 2 is 4. Then the a is 2 and the c is negative 4. And so final answer, it ends up being x equals 7 plus or minus the square root of 81, which I know, all over 4. X equals 7 plus or minus 9 over 4. That breaks into 2 parts, 7 plus 9 over 4 and 7 minus 9 over 4. And this one, 7 plus 9 is 16 over 4, which is 4. And 7 minus 9 is negative 2 over 4, which is negative 1/2. Raise your hand if you had those 2 correct answers. Awesome. All right. So you guys have about a little less than a half an hour, about 20 minutes, 22 whatever minutes left. Your job, review. You've got Schoology quizzes. I recommend that you, by the time you're all done, that you have done 2 of every kind. 2 probabilities, which we already did, 2 quadratics, and 2 of the transformation ones. But the quadratics ones, if you're going to go short anywhere, the quadratics ones, if you only get one of those done, I could live with that because that's the most recent test we had and thus the freshest in your mind. Last question before I stop the video. Yes, sir. Question on the final. The final is all multiple choice. That's correct. Probably in the 70s, like 77-ish. You'll have to work most of the time, but most of you will finish with some time to spare. We really haven't had trouble with people finishing this thing. The second semester final is tougher, but this one's not that bad, lengthwise. Yeah, you have free time after you finish it. We can't let you leave. We can't let you be on electronic devices. Too easy for you to be like texting your friends answers or whatever. So no electronic devices for after the final. Plan to just draw a picture or something. Read a book. Do some homework. Yes? Calculators are allowed on part of it, but not all of it. It's like a half and half deal. Because there's a white part and a yellow part. And the yellow part you're allowed to use a calculator, and the white part you're not. Any other questions? Okay, that's all I got for the video then for today.